there is an Earth-sized world 22 light-years away. The Hubble Space Telescope has measured the closest transients planet to us. The world, classified as LTT 1445 AC, is almost identical in size to Earth, but slightly more massive. It is approximately 22 light-years away and is the closest Earth-sized rocky planet known to us. The planet LTT 1445 AC was discovered by NASA's Transients Exoplanet Survey Satellite (TESS) Space Telescope in 2022, but its size has only now been confirmed. TESS was specifically designed to search for extrasolar planets. Scientific instruments mounted on the telescope monitor vast areas of the sky in search of planetary transits, i.e., situations when a planet passes in front of the disk of its star, viewed from the perspective of the telescope, which causes regular decreases in its brightness. The degree of dimming and the almost imperceptible movements of the star caused by the planet's gravitational pull allow researchers to determine the size and mass of the exoplanet. Initially, scientists weren't sure whether they could accurately determine the size of the exoplanet. Preliminary data showed that this world only glided across a small part of its star's disk. TESS did not allow for better characterization of the planet. However, observations made with the Hubble telescope showed that the planet was making a normal, full transit in front of the star. Although there are many exoplanets closer to us, LTT 1445 AC is the closest to transit. There was a risk that this system had unlucky geometry, and if it did, we would not have measured the size of the planet. However, thanks to Hubble's capabilities, we managed to determine its diameter, said Emily Pass from the Center for Astrophysics, Harvard and Smithsonian. The researcher is the first author of an article recently published in The Astronomical Journal, describing the measurements of LTT 1445 AC. With the appropriate data, scientists were able to determine the size of LTT 1445 AC. It turned out that its diameter is only 1.07 times that of the Earth. Its mass is 1.37 times greater than that of Earth. However, with a surface temperature of around 260 degrees Celsius, it is too hot for life to exist there, at least as we know it. These temperatures result from the tight orbit. LTT 1445 AC orbits its star in just over 3 days. This world has a density of 5.9 grams per cubic centimeter. For comparison, the Earth has a density of 5.51 grams per cubic centimeter. The planet orbits the star LTT 1445A, which is part of a triple system of 3 red dwarfs. It is located approximately 22 light-years away in the constellation Eridanus. The system's 2 remaining components, stars classified as LTT 1445b and c, are approximately 8 billion kilometers away from LTT 1445a. In 2019, another planet, also rocky, was discovered there. LTT 1445a flat is 1.3 times the size of our planet, but has a mass more than 8 times greater. It orbits its star once every 5.4 Earth days. The temperature on its surface is about 155 degrees Celsius. The planet LTT 1445A also orbits LTT 1445A. It is located in the so-called the star's habitable zone, i.e. the place in the orbit where conditions may exist to support the presence of liquid water. Unfortunately, LTT 1445A does not pass in front of its star from the perspective of a viewer on Earth. Because of this, scientists do not have enough data to further characterize this world. But they have additional data on the transit of LTT 1445AC obtained by the Hubble Space Telescope. Perhaps they will allow us to look into the planet's atmosphere, if it has one. Scientists will be able to determine its composition. A planet with an atmosphere passing in front of its star not only dims the light, but also changes it based on its chemical composition. This allows scientists to analyze changes in the light spectrum and determine the composition of the atmosphere. Transient planets are exciting because we can characterize their atmospheres using spectroscopy, not only with Hubble, but also with the James Webb Space Telescope. Our measurement is important because it tells us that this is likely a world very similar to Earth. We look forward to further observations that will allow us to better understand the diversity of planets orbiting other stars, Haas said. Satellite photos revealed traces of several hundred huge structures dating back 3,000 years. Using satellite and aerial photos, archaeologists found a network of previously unknown huge structures located in Central Europe, along the Tisza River. Scientists indicate that these structures, over 100 of which have been discovered, were built over 3,000 years ago. The remains of ancient buildings were first noticed in photos from Google Earth in 2015. Archaeologists simply wanted to see if they could find something interesting that had been missed in ground research. The analyzers concerned the area of the so-called Pannonian Basin. It is a vast plain in Central Europe covering parts of Austria, Hungary, Slovakia, Slovenia, Romania, Ukraine, Hungary and Serbia. Scientists analyzing satellite and aerial photos discovered over 100 previously unknown, huge structures. According to them, these structures were built in the Bronze Age, about 3,000 years ago. Placed close to each other, they form a strip stretching for 150 kilometers along the Tisza River. Scientists speculate that the buildings were part of an extensive network of settlements established during the period of dynamically developing trade in the region at that time. The results and description of the research were published in the journal, PLOS One. Among the over 100 structures spotted in the photos, many were identified for the first time. Some of them are invisible from the ground because they were simply plowed up after decades of intensive agriculture or destroyed in prehistoric times. After identifying the structure in Google Earth photos, scientists from University College Dublin, together with colleagues from universities in Slovenia and Serbia, flew small planes over the area, taking photographic documentation. Then they went to the site in person. On site, in various locations, they found fragments of pottery, ancient querns, various agricultural artifacts and animal bones. By comparing the pottery found with others discovered in the region, scientists determined that the structures were built sometime between 1550 BC and 1200 BC. Radiocarbon dating of animal bones confirmed this range. Aerial photos perfectly highlighted traces of defensive palisades and wooden fences. Trenches were dug near them. The whole thing protected the settlements inside. The artifacts found suggest that at least several multi-generational families lived in each such settlement. However, what the structures inside the stockades looked like and whether the structures were occupied year-round remain unclear. Scientists haven't found much evidence of defensive homes or other permanent structures inside the palisades, although they hope to find some in the future. It is possible that these defensive structures were seasonal meeting places or ceremonial centers. Perhaps they were ordinary cattle pens, or maybe they were something completely different. These are new discoveries that change our knowledge about the Late Bronze Age and the Balkans, admitted co-author of the publication Dragan Jovanović, an archaeologist at the Municipal Museum in Vršac. It's amazing that it has remained hidden until now, he added. Why did the ancient inhabitants of these settlements need defensive structures? This too remains unclear. Bronze weapons found in cemeteries near some settlements suggest that their inhabitants were skilled in fighting. Most of the newly discovered structures are located only 5 or 10 kilometers away from each other and are visible from the nearest neighbors' settlements. Protective palisades were built in a similar way. The ceramics found inside the various structures are also similar to each other. According to researchers, it is unlikely that the people living here were enemies or competitors. The fact that they share the landscape means they are cooperating, said study leader Barry Malloy, an archaeologist at University College Dublin. But the inhabitants of the settlements did not live in isolation. Scientists suggest that they were connected to the wider world through trade. They also believe that at its peak the entire network of settlements could have been inhabited by tens of thousands of people. Archaeologists indicate that around 1200 BC, these places are no longer used. Test excavations showed that some of the structures had been deliberately demolished, ditches were filled in and wooden palisades collapsed. The reason remains a mystery. During this time, as the authors of the study emphasize, many settlements from Egypt to northern Germany were also abandoned for unknown reasons. Year 1200 BC was a turning point in the prehistory of the Old World when, within a few decades, kingdoms, empires, cities and entire societies collapsed across a vast area of Southwest Asia, Northern Africa and Southern Europe, Malloy admitted. The Webb Telescope reveals the center of the Milky Way, showing unknown structures. New photographs taken by the James Webb Space Telescope, JWST, have revealed the crowded center of our galaxy in unprecedented detail. With its ability to make precise infrared observations, The telescope allowed astronomers to peer through the gas and dust into the center of the Milky Way, revealing never-before-seen objects. The Webb Telescope captured the center of the Milky Way using a near-infrared imaging device called NIR-CAM, near-infrared camera. The galaxy's heart is obscured by gas and dust, making observations difficult, but JWST's capabilities, especially its ability to detect infrared light, have revealed previously hidden regions and allowed it to image much more detail than visible light observations. The new photo showed never-before-seen objects. The photo shows a small area just 300 light-years away from the supermassive black hole at the center of the Milky Way, Sagittarius A. This is an area of intense star formation known as Sagittarius C, SGRC. Until now, there has been no infrared data from this region with the resolution and sensitivity that we obtain with Webb. So we are seeing many objects for the first time, said the principal investigator of the observing team, Samuel Crowe of the University of Virginia. Webb shows an incredible amount of detail, allowing us to study star formation in these types of environments in a way that was not possible before, he added. The galactic center is the most extreme environment in the Milky Way, where current theories of star formation can be put to the most rigorous test, admitted Professor Jonathan Tan from Crowe's team. The new photo shows approximately 500,000 stars. Among them, marked with an orange circle in the photo below, is a cluster of protostars, stars that are still forming and gaining mass. At its heart is a previously known protostar that, at this early stage, has a mass over 30 times that of the Sun. Scientists predict that the life of this star will be short, of course by stellar standards, in a few million years. This ultramassive object will explode as a supernova, unlike stars with masses similar to our Sun, which can survive for billions of years. The darker areas around this group may appear to be a less crowded area. However, the opposite is true. Scientists say this area is so dense that light from stars behind it cannot penetrate. This is one of the most densely packed areas in the photo with various objects. There are several similar areas in the photo, marked with a green dashed line. The telescope also captured huge areas of ionized hydrogen. These are the bluish or cyan elements of the image, the area marked in yellow. According to Crowe, these types of features in space photographs are the result of highly energetic radiation emitted by young, massive stars, but the area is too large, which surprised the researchers. So they will continue to study this region. Another feature of the region that Crowe plans to study further along. Straight structures in ionized hydrogen, marked in red, called needles. They appear to be oriented chaotically in many directions. The galactic center is a crowded and turbulent place. Webb has provided us with a wealth of data about this extreme environment, and we are just starting to delve into it, said Rubén Fedriani of the Instituto Astrofísica de Andalucía in Spain. Webb's image is stunning, and the insights we gain from it will be even better. Massive stars are factories that produce heavy elements in their cores. Studying them is like learning the history of the formation of much of the universe, Crowe said. The area shown in the photo in question is about 50 light-years wide and lies about 25,000 kilometers away. Light-years from Earth. Full-resolution photo available on the Webb Telescope website. The richest people emit as much CO2 as the two-thirds of humanity with the lowest incomes. According to an analysis published by Oxfam International, the richest people in the world, who constitute approximately 1% world population, are responsible for the same carbon dioxide emissions as the 5 billion people who make up the poorest two-thirds of humanity. The report by Oxfam International was published in connection with the upcoming COP28 Climate Summit, which is scheduled to start on November 30th this year in Dubai. There are growing concerns that limiting long-term warming to 1.5 degrees Celsius may soon prove impossible to achieve. Therefore, for our common good, state policies should be adapted to the changing world. Although tackling the climate crisis is a common challenge, not everyone is equally responsible for this state of affairs. The world's richest 1%, about 77 million people, were responsible for 16% of global CO2 emissions, the report found. The same CO2 emissions were calculated for 66%. People with the lowest incomes. That's about 5.11 billion people. In France, for example, the richest 1% emit as much carbon dioxide in a year as the poorest 50% emit in 10 years. Bernard Arnault, the billionaire founder of Louis Vuitton and the richest man in France, has a carbon footprint 1,270 times larger than the average Frenchman. But this is a result that does not take into account the emissions associated with its investments. The richer you are, the easier it is to reduce emissions both personally and through investments, said Max Lawson, co-author of the report. You don't need a third car, a fourth vacation or to invest in the cement industry, he added. The super-rich are plundering and polluting the planet, leaving humanity suffocating in extreme heat. Floods and drought, said Oxfam International chief Amitabh Bahar. For years we have fought to end the era of fossil fuels to save millions of lives and our planet. It's becoming increasingly clear that this will be impossible until we also end the era of extreme wealth, Bahar said. The report, Climate Equity, A Planet for the 99%, is based on research by the Stockholm Environment Institute, SEI, and assesses greenhouse gas emissions across different income groups. It shows the clear difference between the carbon footprint of the world's richest people and the rest of humanity. According to him, the richest 1% are responsible for 16% of global emissions from consumption. The richest 10% are already responsible for half of emissions. We believe that unless governments implement progressive climate policies that ask the people who emit the most to make the greatest sacrifices, we will never reduce global warming, Lawson said. The authors of the report suggest that governments could introduce a tax on flights more than 10 times a year or a tax on investments in low ecological industries that would be much higher than the tax on ecological investments. While the current report focused on carbon emissions tied solely to individual consumption. The personal consumption of the super-rich is dwarfed by emissions from their investments, the report said. Rich countries are much more responsible for global warming and must, according to the report's authors, bear the appropriate costs. New taxes on corporations and billionaires could help pay for the transition to renewable energy. Lack of taxation on wealth allows the richest to steal from us and ruin our planet. Taxing extreme wealth will transform our chances of fighting both inequality and the climate crisis, Bahar said.